All right, so what we're going to talk about here today is really, really, really important. It can make a huge difference in your life, okay, and in your family's life and all kinds of stuff. It's the idea of interest and how does interest actually work. The other day we talked about how does interest work on a credit card. You saw how it compounds at a rate of about 1.5% a month, okay? But what I want to do today is to get through a variety of examples. Let's see here, there we go, of different types of interest. There is more than one type of interest. Interest is money that some firm, bank, credit union, investment group pays you when you loan them your money for a while. So for example, okay, we have some money invested in different retirement accounts. We have some money invested with a financial advisor. What happens with that financial advisor is they take that money, they invest it in stocks, bonds, mutual funds, things like that. We expect them to make more money than what we gave them. And I keep track of how much they earn from the money we gave them every year. I don't watch it every day. The stock market's up and down and it's just too crazy. The way they make a living is they keep a small percentage of the money that they make off of the money you loan them. And I do mean loan them because at some point, Becky and I are going to come back and say, hey, start sending us some of this money. And they'll say, yep, you got it. It's your money. But what winds up happening is we send them some money. That money is called the principal. Not like the person that runs the high school. Okay? Then, each year, they invest that money in different companies, and the companies, for being allowed to borrow that money, pay them some interest. Just like when you go out and you buy a car and you take out a loan and they charge you interest on it, that interest is you paying them for the use of that money. Does that make sense? That's what interest is about. Somebody's getting paid because they loaned somebody else money. They provided money to another person for a period of time, and in exchange for having used that money for a period of time, the person pays them additional. Two ways that interest is compounded. Okay? The first way is what's called simple interest. Simple is exactly what the name implies. It's mathematically, it's not hard to do. We're going to take a look at that. Then there's a second type of interest called compound interest. This is oftentimes a little bit more challenging to compute. Not horrible. You can do it. But what this does, and this is really important because this is where it kills it for you, where it really brings things in. Interest in simple interest is only paid on the original principal. So for example, if I borrowed $100 from you at 10% simple interest, that means each year I would have to pay you 10%. What's 10% of 100? $10. So, if I borrow some money from Jack, $100, okay? Dude, I got to take Becky out to Texas Roadhouse tonight, and I've got to leave Jory a good tip. You got $100. I'll pay you back later, okay? I pay him interest for the opportunity to use that money to take Becky out. The way simple interest works is if it takes me 4 years to pay him back. Geez, really? What I have to do is every year, as Jack said, it would be $10 per year interest. Every year, I would pay him $10. So in 4 years' time, I would have paid him $10, $10, $10, $10. So he would get the $100 back at the end of 4 years and $40 in interest. Each year I just pay him back the same amount of interest. Does that make sense? That's simple interest. You figure out what's the interest on it, and you just stick with that, and every year you get that amount. Compound interest, if you compound something, that means you add it on to top of something else, right? Don't compound the problem by saying something stupid. That's something I've learned as a husband. Learned it the hard way. Okay? Compound means you add it on to what's already there. So what happens with compound interest is at the end of the first year, I would owe Jack the $100 plus $10 in interest. The second year, the interest would be on the $100 plus the $10 I owed him from the year before. So the interest I'm going to pay him is not just on the principal, but on last year's interest. So the second year, the interest that Jack gets goes up. The third year, I have to pay him back the interest on the $100, plus I have to pay him interest on the other interest that I've paid him or owe him.
So it's like $100 then.
Yeah, and we'll take a look at some examples of how this adds up. But what winds up happening is it compounds. There is a massive difference between simple interest and compound interest. When you start a retirement account or investments, it's usually seen in the light of compound interest. I'm hoping by the end of this class you'll see, I mean, you can kill it this way. Okay? Does that make sense? Real important that you understand what the principal is, what simple interest is, and what compound interest is. Okay? It's kind of like if you came out to our place and I said, don't touch the bull, but give this to the cow. Is it important that you know the difference between a bull and a cow?
Yeah.
Yeah. Yeah, in capital letters. Okay?
One has horns, one doesn't.
That's not true.
Well, sometimes they don't have horns.
A lot of times they don't. Yeah. Owen was going for the horns thing. Depends on the breed. Or if they're polled or not. You can actually...
You also don't eat their meat because testosterone, if you don't know. You also don't eat bull meat usually.
So, well, let's go on from there. Okay? It's important you know the one from the other. The bull will stomp you into the ground. The cow will take the food usually. Okay. An example. Savings bond. You invest $1,000 in a savings bond that pays 10% per year. What's the total interest you receive in 5 years? Okay, simple interest. First off, 10% per year. What is the principal? The $1,000. That's how much money you take to the bank and you say, I want to buy a savings bond. The principal is that. The interest is the 10%. Now, with simple interest, every year you're going to get 10% of $1,000. What's 10% of $1,000? 100. So when you come back in 5 years, they're going to give you back your $1,000. Plus, every year they're going to pay you $100 for 5 years. So in 5 years, when you come back, how much money are they going to give you? $1,500. Does that make sense? The $1,000 that you loaned them, and that's really what happens when you invest it, you're loaning it to them. You get back the money that you gave them plus the interest on it. You get the same interest every year with simple interest. Okay, so there's your interest. It's the 10%, 5 years, bingo. Now, with compound interest, the interest you get each year grows. In the second year, Jack will get more interest than he did in the first year. In the third year, he'll get more interest than he got in the second year. with the difference being, okay, the first year payment, you've got the $1,000 in there, and go multiply it by the 10%. So the first year, Jack would get $100 in interest. Now, that $100 doesn't come to you right then. It stays in the account. The second year, how much money is in your account? The $1,000 plus the $100. So the second year, the amount of money in the account is $1,100. So the first year you get $100 interest. The second year, how much interest do you get? $110 interest. Okay, so the third year. Now remember, at the end of the second year, there's $1,100 in there, right? Then they add another $110. So this means you're going to have $1,210 in the account the third year. The interest you will receive the third year is 10% of that, which is $121. Do you see over on the right-hand side how the interest you're getting each year is increasing? Have you given them any additional money, or is it still that original $1,000?
The original 1,000, but it's now just you're shifting the index upwards, so you're getting more and more of it.
That's right.
The index is shifting.
This is going up each year. Now, you may say $10, $20, whoopee ding. When you leave money invested for a period of time, this does become amazing. Does this make sense how compound differs from simple interest? Okay? So here's the first thing I want to make sure that you're aware of. What this winds up doing is that things grow at a faster rate. Yes, ma'am?
When people do savings bonds then, like, do the people who run the savings bonds like really like benefit from this? Like,
Okay, yeah, and one of the things that we're going to talk about is when and how do you invest. Savings bonds are usually associated with the Treasury, the U.S. government. And most people are hoping, or finding out that maybe they don't handle money as great as we even thought they might. Okay? But the idea of a savings bond is when you put the money there, the odds are the government's going to be around in 10 years. The country's going to be there. So you're going to get your money back. It's a fairly safe place to put money. With those bonds, they do not offer as high of an interest rate. Now, on the flip side, there's some new little startup company. You start up a new company selling candles, okay? Or just selling general odds and ends items on the internet. Let's say it's 20 years ago and you get this idea, I bet you I could sell stuff on the internet. And you need some money to support that, so some people loan you some money. In exchange, you agree to pay them a percentage of the money each year based off of how the company grows. Now, if Owen loans you some money to get your company going, he understands there's a risk that your company may not be there 3 years from now. And if your company's not there, does he get any money back? No. You tried, it was worth a shot, didn't work out. If on the other hand, you decide 5 years into this, I think this is going to work, but I need to give it a different name. I'm not going to call it Emma's anymore. I'm going to call it Amazon. Now, is Owen going to get a whole lot more than his $1,000 back? He's going to be killing it, isn't it? The difference there is that he took a risk. Oftentimes, the more risk that you take on an investment, the greater the gain if it works. Treasury, you put it in, you get some back. My wife's grandparents, as they got older, They put their money in things where they knew they were going to get their money back. Okay, when you start hitting 60 and 70, you don't have a whole lot of time for it to grow back if it goes belly up. If your company goes bankrupt, Owen doesn't have a lot more time left to earn more money. So they want to put it someplace where they're going to get some interest, but it's safer, more likely to get it back. That's what those types of things are about. Okay? That's for later on when you retire. Now, you don't want that. Okay, real important. If you have compound interest, that means that every year you get paid interest on the interest from the year previous. It compounds. If it is paid once a year, here's the formula. Now we're going to boost it up from this. Okay, we're going to wind up with a different formula. It's a little bit more modified, and that's the one you're really going to want to hold on to. Yeah?
Will we be using these formulas, like should I probably write this down?
You're going to be using these formulas, yes. Okay? The things I want you to walk away with from this slide are A represents the total accumulated amount. Okay? So when you come back in 30, 40 years, A is the amount of money in that account. P is the principal. That's the amount of money that you put into the account. The APR, really important you know what APR is. It's the annual percentage rate. Real important is a decimal. You're going to see APR written like this. APR 8.7%. Do not use the percent. You'll wind up with crazy returns, huge returns. The catch is this is a percent. You need to convert it back to a decimal. Cent means 100. That means we're going to divide by 100, which means move the decimal over 2 places. 0.087 is what you use in the equations. Y, where's Y? It's up here in the exponent. It's the number of years you leave this thing invested. So for example, your first year at your career job, you invest some money. You're probably going to be there 45 years or somewhere. So Y would be 45 years. Your second year, is that money the second year going to be invested for 45 years? No, it's only going to be invested for 44 years. 1 year less, right? You're a year closer to retiring. You've already got a year in. Okay? At that point, don't worry about retiring. Just focus on the job. Okay? Now, what this table here does is it allows you to compare simple interest versus compound interest over a short period of time, the difference. And I will grant you, I will agree with you every day of the week, it's only $11 difference. Who really cares? It's only $11 over 5 years. Whoopie doopie. That's $2 a year.
That's
Okay? Early on, it doesn't look exciting. It's after it's been there for 30 years, 35 years that, gee, money, it really grows. Okay? With the simple interest, the exact same amount of interest every year, isn't it? With the compound interest, what's happening to the interest every year? It's going up, isn't it? And the interest goes up faster as the balance goes up. Okay? Okay, so I'm going to skip this for right now because I want to get into some other things. Here's what I want to get into. This is the equation we're really going to use. This one is the important one. In fact, this one will get you back to the first one. A is still the amount of money that you have after so many years. P is still the amount of money that you gave them at the start. The APR is still what's the percentage or the interest rate. here's where it differs. N, in two places, is the number of times per year they pay interest. If it's annual, what does the word annual mean?
Once a year.
Once a year. Semi-annual means they're going to pay it twice a year. Quarterly, quart is 4, they're going to pay it 4 times a year. Monthly is how many times a year? 12 times a year. Now this next one gets a little odd. Daily is 360 times a year. Well, dude, there's 365 days in a year. When they started this, they didn't have computers like they do now, and they had to do all these computations on every account. Think about working at a bank, and you've got to be computing the balance with interest on every account for every customer at the bank. That's like a lot. So they just said, look, 365 is too hard to work with. We'll just go with 360, close enough. So daily means N equals 360. And Y is still the number of years. Okay, so how does this work? Are you okay, or you want to take a picture of that? Let's see, I'll get these arrows out of the way here for you so you can actually see the equation. Okay, this is the equation you're going to need to know how to use. On the quiz, I'll put it on there. By the test, probably not. But the frustrating part for some people is they think, it's on the quiz, I don't have to study this. Now on the quiz, it's, what does A mean? What's P? What's N? Well, that's part of the quiz. Okay, so be sure you know how to use it. And let's take a look at how this would work. Okay, we deposit $5,000 in an account. What's that $5,000 that we deposit called? P. That's the principal. APR is 3%. The interest compounds monthly, so that's the code word for N equals what? How many months in a year? 12. Okay. After 5 years, this is the number of years. Do you see how you can pick through this and pick up the numbers that you need? And then all you need to do is for the amount that you're going to be owed, how much they're going to pay you at the end of 5 years, it's going to be the principal times 1 plus the APR. Do we put 3 there?
No, 0.0.
No, it's going to be slide the decimal over 2 places, divide by 12, because you don't get 3% a month. You get 1/12 of that every month. Raise to the 12 times a year that you're going to get paid interest times or over 5 years. Are you okay? Now, one of the things I would really hope that you would do here, this is another thing people ask is, well, I don't know how to put this in my calculator. So let's step through putting this in your calculator. Going to leave the 5,000 there for right now. Times, I'm going to do 1 plus 0.03 divided by 12 equals. And inside the parentheses, I'm going to have 1.0025. Are you with me on that? What's 5 times 12? 60. Okay, so the exponent's going to be 60. Whoa, are you glad you got a calculator, or how would you like to multiply that together? 60 times. Now, do you see the 1.0025? Raise that to the 60th power. Chuck, I don't know how to do that on my calculator. Okay, you're going to have one of 2 keys on there. Y to the X. That's how some of your folks' calculators display it, and some of them have something like that. Depends on the calculator. Okay? If you have this first key, you're going to do the 1.0025, press that key, and then raise it to the 60th power.
Then multiply by 5,000.
Yep. If you have this second one, you're going to do 1.0025, raise it to the 60th power. Now, when I raise this to the 60th power, I get 1.161616. Did that work? Now, the cool thing on your calculator is, leave that number there. Don't erase it. Don't delete it. This whole portion of the equation is now wrapped up in that number. The only thing left to do is to, that's right, so you just press times 5,000. And it'll bring along that 1.16 number. And in the end, you're going to have $5,808.08.
I can't find that button on my calculator.
Hmm?
I can't find that button on my calculator.
Jory might be able to find it for you. To the rescue. Does this make sense to you? Make sure that you can do this. And if you're having troubles with it, ask somebody around you. Some calculators might not have it, in which case, get a different calculator for Friday. You don't have to get a $1,000 calculator. Borrow somebody else's.
How did you get the 1.0025?
1.0025 came from taking 0.03 divided by 12, then plus 1. This is, please excuse my dear Aunt Sally, isn't it? You start inside the parentheses. Excuse is now the exponent. My is multiply. There it is, please.
I did the 0.3 divided by 12 and I got like, 1/10.
Okay.
By, negative 3.
Yeah, it's working now?
Yeah.
You're okay? Fantastic. Is everybody okay with this? How many of you coming up with this? Or is Jory coming with a different calculator to your rescue? There we go. Okay, now, if this was quarterly, the only thing that would change on this equation is what?
It's now
Quarterly.
6. No, 4.
N would now, instead of equaling 12, would equal 4. Everything else would work the same, except wherever there was a 12, you would put down a 4. If it was daily, you'd put in 360 where the 12 is. Does that make sense? Okay, so this allows you to compute interest at different rates. Okay, so that's got that. Okay, so there's everything plugged in. Bingo, there it is. There's what we got. You're all good. If you were to just take this and compare this to simple interest, see at the bottom of the screen? Okay, that's the simple interest formula. Is there a difference there? Yeah, there's over $800 difference there now. Oh, is $800 worth messing with? Would you cross the street to get $800? I don't know, it depends on the street. But you can start to see there's a difference in the amount of interest accrued, isn't there? Okay. Okay, so I want you to see there's a big difference as you get more into the numbers and into more years. Simple interest is drastically different from compound interest. Big time different. You don't want to mess with simple interest. Okay? Now, there you go. Okay, now, we talked about APR, annual percentage rate. What happens is, if you're getting 10% interest and it's compounded monthly, every month the amount of principal that you have gets a little bit bigger, doesn't it? So when you take 10% of that little bigger number, by the end of the year you've really made more than just 10% on that principal. And it starts to get kind of confusing. Well, gosh, which is better? Quarterly interest is 7.3%, monthly interest is 7.2%, or simple interest of 8%. And you'll see this kind of stuff going on when you go to banks and credit unions and stuff. You've got to watch it. Because somebody could be offering an APR of 7.3%. Simple interest. You walk across the street, there's a different bank or credit union, APR 7.2% compounded monthly. Well, it's kind of hard to tell which of those is really going to do better for you, isn't it? The annual percentage yield, what does the word yield mean? How much you actually get. What the yield does is it takes whatever interest rate they're computing at, however often they're compounding it, and it converts it all back to if this was simple interest. Now, if the APY is 7.4%, and the APY, I'm just making this up, is 7.43%, which of those is actually going to pay you more in the long run? The first one or the second one? The second one, because the actual yield is a little bit higher. Do you see that? When you walk into a bank and they've got those little placards up, or you go online to your bank and they do the things that flash up, in big letters it says APR. I don't care what the APR is. I want to know what the actual yield is, the APY. Oftentimes that's down in the fine print. For one reason, most people don't have any idea what it even means, and they wouldn't know what to do with it if you gave it to them. Okay? But what you really want to concern yourself with is what is the actual yield, and pick the one with the higher yield if you are investing. Now be careful, if you are taking a loan out, do I want the higher or the lower APY if I'm borrowing on a car? Lower, because I don't want to pay as much, do I? If I'm investing in some kind of a certificate of deposit, do I want the higher or the lower? The higher. So be careful, because on the quizzes I throw it out in both directions. You're taking a loan, here are two APRs with their APYs. Which bank do you deal with? Okay? You're buying a certificate of deposit, here are two banks, here are the APRs, here are the APYs. Which one do you want? Be careful. In some cases you want the higher one if you're getting paid. You want the lower one if you're paying. Okay, so does that make sense on those? Okay, the APY is only going to equal the APR if it is compounded annually. They're only going to be equal if it's compounded annually. Any other time, the APY should be bigger than the APR. Okay, there you go. The APY is bigger than the APR if it's compounded more than once a year. Okay, so this one just gives you some idea of how things differ based on the number of times per year the interest is compounded. Notice if the APY is only compounded once a year, that's n equals 1, you get 8%. Way over here in the lower right-hand corner, holy mackerel, that's hundreds, thousands. If it's compounded 1 billion times a year, that's like a lot. Notice how much the APY, the yield, goes up. It's an extra 0.32%, isn't it? It changes things. Okay. One of the things to realize here, let's go back to this for a minute. As you look at the percents, do you see that they go up, they go up? This isn't going up a whole lot. At the first, it jumps a whole bunch. It jumped from 8 to 8.2, didn't it? Then it stays at 8.2, something or other. It eventually gets to 8.3, something or other. As you increase the number of times it's compounded, the APY grows more slowly. That's what this graph is saying. The red line here is at the beginning, when you go from 1 time a year to twice a year, it's compounded to 4 times, it really bumps up the yield. But after a while, it doesn't really make that much difference after a while how many times it's compounded, because you're basically getting the same amount. Now, the very last entry in that table was compounding 1 billion times a year. That's like every second or so, isn't it? I forget exactly how many seconds there are in a year. We could figure that out. That's back in chapter 2. It gets to the point where every second, basically, you're getting interest all the time, aren't you? That is what is called continuous compounding. Catch this, okay? Continuous, because it changes the equation. Continuous means you're always getting the interest on what you just had 1/10 of a second ago. As you get the interest paid more often, remember how that graph went up, 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 but then it leveled off? This equation here is what it levels off to equal. This is the equation for continuous compounding. Okay, so let's think about this a second. There are 2 equations you need to know. The one several slides back, where you had the P times 1 plus APR over N to the NY. That's when you compound N times per year. That's compound interest. That's one of the equations you need to know. The other one is this one. The way I remember this one, there used to be a shampoo out. I don't know, it may still be out, called Pert. Who knows? Okay? They still have it? Okay, a different way to write this formula is P e to the rate times time, or the number of years. Oh, Pert. There it is. It's the shampoo. Okay? So, on a quiz or something, if you come up, gosh, Chuck, I forgot what continuous compounding is, I'll just say, gosh, go wash your hair. Hint, hint. Okay? Pert. Sometimes people look at me kind of weird, and other people in the class are giggling. How does this work? This is going to be the highest annual percent yield. This is the best you can do. The way this works, there we go, is as follows. And this brings us to what I want to do with your spreadsheets. On your spreadsheet, let's see, we've done May, June, July, August, September, 5 months. Okay? On your September balance sheet, go down under the second or third grouping. Here, let me find one of the balance sheets, the budget sheets. Here we go. Okay, in the section titled Savings, about the third group down. Do you see there where it says Retirement? Over to the right-hand side, way over to the right-hand side, way over here, is one where it says total saved by EOM. Any idea what EOM is?
End of month.
End of month. If you look at the retirement, this person has $2,916. Do you see your retirement? Your amount? Applying to you with the job that you have? Jot that number down. Now, that's for May, June, July, August, September. That's 5 months. By the end of the year, that's going to be more than double, isn't it? So what you want to do is double that number, whatever it is. So for example, if my number was 3,000, doubling it would be 6,000. But that's only 10 months, isn't it? Then, over on the left-hand side where it says how much was taken out that month, do you see that? You still got 2 months coming, don't you? So you take that times 2. 2 months. So let's say for me that's another $1,000 bucks.
Times we're supposed to multiply like our basic amount, like
2,
okay.
because there's 2 more months. When you double the number, that gets you 10 months. But there are 12 months in a year. Okay, so you take another 2 months of depositing it in, and let's say this is, I'm just making something up, $67.50. Okay, well, big deal, Chuck. What's $6,000 going to do for me at the end of my career? Does everybody have a number there now? Do you have your number?
4,400.
Do you have it? Has everybody got it? Okay, we are going to assume that you put this in a halfway decent account. I am not going crazy on the estimate here because notice it says, what's the interest rate?
8%.
8%. Okay, so is 8% very good or not so great? Well, truthfully, in the stock market, in the long run, over the last 100 years, it's averaged 10% a year. So what I'm doing here is I'm giving you a very or a somewhat conservative estimate, and the pen stopped writing. Okay, did this to me before. I think this pen, I don't know if the battery runs out on it or what. But what we're going to do here is, if you want to get closer to what it's realistically going to be in the long run, you would put in 10%. But let's be conservative. 45 years from now, if you've got more money than what you expected, are you going to come back to me and say, dude, you really messed up. I've got more money than what I was. It's going to be, yeah, I'm glad I listened to him. Wonder where he is. Okay? To figure out, and this is amazing, to figure out what's going on here, you take whatever your number is. I just said suppose it's $6,000. You take whatever your number is, you multiply it times, well, wait a minute, what's this E thing? On your calculator, you should have a button that says E and then X up in the exponent. Okay? So what you're going to do is you're going to take 0.08 times 45, and I've got it worked out for you. It's really 3.6. So you do e to the 3.6, or if you calculator, there are 2 ways these calculators work, so you're just going to have to experiment, which is why I'm hoping you'll do it now. Try putting in 3.6 and press e to the x. And see what it gives you.
Syntax error.
Okay, so if it blew up on you, that's fine.
It has to, I think it has to do it like this.
Okay, yeah, you're just going to have to experiment with your calculator and see which way it works, because different ones work different ways. But what's going to wind up happening is, if we do this, e to the 3.6, you should come up with 36.598. When you get it to work, it should be 36.598. Are you getting that to come out? So whatever keystroke combination it took to get that, there's the combination you need to use. Now watch this. This 36 point, whatever that was, times 6,000, or times your number. If it's 6,000, that's $219,000. What does that mean? Do you know what?
1,780. Yeah.
That sounds about right, because you said you were in the 4,000s.
Yeah.
Okay. You know what that 219,000 means? Yeah.
Is that how much like you'll have saved in your retirement after 45 years?
From this 1 year. Did you hear what I just said? From this 1 year. So year one, in 45 years, will have grown to $219,000. Keep this up every single year. Year two, it's not going to be as much because it hasn't been in as long, has it? Let's say it's $210,000. Year 3. Do you see what's happening here? Do you get the pattern? And for how many years is this? Well, it depends how long you work. You may get enough money saved up that at 58 you say, you know, I got more money I can spend now. I'm retiring. But what you wind up doing is you add up all of these. And that's how much money's in the account. Now, this is if you're a complete loser, deadbeat, embarrassing employee. This is the worst you can do. Why is that? Because that's right, no raises, no promotions. Because as you get raises and promotions, what happens to the amount of money you put in? It goes up. Do you get the point on this? Okay, 45 years from now, don't come back crying to me, well, gosh, Chuck, I don't have enough money to retire on. Because I'll just smack you and say, not my fault. Okay. This is one of the coolest things, I think, they get to share with you guys. It gives you a hope for the future. Some of you have parents who were never shown this. And they're trying to figure out, they're scrambling, trying to figure out how on earth are we going to live. You don't need to be one of those. My wife's parents knew this stuff. Okay? Howard was very faithful about putting away money every single month. That's what Judy said. She said he always put away the maximum he could every month. I forget if I've shared this problem with you or not. When Howard went to retire, I said, let us know if you need help because we'll rebudget and help you. A year or so later, he came back and said, Chuck, we've got a problem in retirement. Do you recall this story or not? I haven't shared it. Good. You know what he said his problem was in retirement? They've got too much money. The interest coming in off of what they have, not the money, just the interest is more than they could possibly spend in a year. Now that problem gets worse every year because now you got money you didn't spend, so what do you do with it? You invest it. And then next year what happens to the amount of money you have? It's more. And do you see what winds up happening?
Taxes.
Okay? Depends how you invest it. Okay? I want that to be your problem when it comes time for retirement. Crud. My problem is I can't spend all the money that's coming in. How would you like to retire like that? Is it possible? Do you have to be a neurosurgeon to do that? No. Do you see that with what you have, you can be there? Don't ever let your broke friends tell you, oh, you'll never be a millionaire or whatever. That's just not true. But you got to start when? Day one. And don't stop. Are you okay? Does that make sense? That is one of the coolest things I get to share with you. I'm so excited because I just showed how each of you can be a millionaire and be absolutely fine when it comes time for retirement. No problems at all. Or even retire early. Let's see here. Get this puppy to stop.